All right, so we are on day 3 notes of Unit 9, and we're going to simplify radicals today, which seems like we've already have. We've simplified square roots, okay, with just numbers underneath them, but we're going to simplify algebraic radicals, which have variables underneath them as well. And not only are we going to do square roots, we're also going to do cube roots and fourth roots and possibly even fifth roots. All right, but as soon as we start to learn the process, we just apply that process to whichever number is in the crack, which is called the index, okay, or the nth root. All right, so it says in number 1 here, we're going to begin our discussion on radicals by talking about the principal square root. All right, so in number 1, and it says evaluate the expression square root of 9. Remember, square root of 9 is a perfect square, and so the square root of 9 just becomes 3, and that's our answer. Okay. We have to remember in number 2 that if we have an equation, then there's 2 answers, all right? And we can typically get those answers by factoring, and that's AD to PS. And so we could factor it into x plus 3 and x minus 3, and then each factor gives us an answer. So this answer would be x equals negative 3, and this answer would be x equals positive 3, okay? So when it's an equation, we actually get 2 answers, okay? If we're just evaluating the square root of 9, though, we just have that one answer of 3, okay? And that's called principal square root, all right? The other way that we could have solved this question is that we could have added 9 to the other side, and when we add 9 to the other side, it's going to turn into what we see in number 3. And so the other way to solve the equation, instead of factoring and getting equal to 0, is that we could square root each side of the equation. And when we do that, that's an even root because there's a 2 in the crack, right? And we have to remember that even roots have 2 answers. We've talked about that earlier this year, okay? And so not only do we have x equals 3, we actually have x equals negative 3 as well. Because if we put negative 3 in for the x and we square negative 3, we get 9. If we put positive 3 in for x and we square it, we also get 9, okay? So 3 squared equals 9, and so that's why 3 is an answer, and negative 3 squared is also equal to 9, and that's why we have 2 answers there, okay? All right, and we'll go down, and let's take a look at what we have down here. It says, we only consider a radical simplified when all of its perfect factors have been evaluated, okay? So when we do these, we're going to break the radicand, which is what is underneath the radical, into 2 factors, okay? And I always like to put the perfects first, okay? And you just have to remember that if you want it to be in simplest radical, that you have to have the largest perfects, all right, in our first radical, okay? And the non-perfects will go underneath the second radical, all right? So place the perfect squares found in step 1 under the first radical sign, and place the divisor, or what's left over, the other factor, under the second radical sign, okay? Then we're going to take that first radical with all the perfects, and we're going to take the square roots or the cube roots of all of those, right? And they will live on the outside. And we're going to try to have the smallest amount underneath the radical left over, and that way it's going to be in what we call simplest radical form. All right, before we do these, some people call them VIPs, very important perfect squares. And we know our perfect squares are 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, 9 squared, which is 81, and 10 squared, which is 100, and they keep going. So we might need more, all right? Remember that any variable that has an even exponent is also considered perfect. So for instance, x squared is perfect, x to the 4th is perfect, x to the 6th is perfect. And remember, they don't have to use x. They could use y, they could use z, they could use b, they could use a, all right? But remember that any even exponents, okay, are considered perfect squares. Okay? All right, so here we go. So in number 4, we're going to go ahead and keep that negative 2 on the outside. We won't use it for a little bit. 96 isn't perfect, so we break it up into the largest perfect. That goes into 96, and that number is 16. And it goes in 6 times. And there's no perfect that goes into 6 other than 1, and that's how I know that 16 here is the largest perfect. And the square root of 16 is 4. The square root of 6, which is the non-perfect, comes down. The negative 2 comes down, and there's no operation in between the negative 2 and the 4. And we always take that as multiplication when there's no operation shown. All right, we do the multiplication here. We end up with negative 8 square root of 6. And now that is in simplest radical form. It has the same value as negative 2 square root of 96, but it has a lower number underneath the square root, and that's why that's considered simplest radical form. All right, so now we're going to talk about variables. All right, remember when it's a square root, we're looking for even exponents, and 25 is not an even exponent, okay? All right, when we do exponents, okay, I'm going to put that 2 in the crack there. When we do exponents, whatever the number in the crack, that 25, that exponent has to be divisible by 2, and 25 is not divisible by 2. It doesn't go into it evenly. So what we're going to do is we're going to go to the next lower number. So we're going to go b to the 24th. Now 24 is divisible by 2, and so we're going to now split this up, okay? Remember, there's a 2 in the crack, and I find it helpful to put it there, all right? So we got b to the 24th. That is the largest perfect that goes in, that we can break up b to the 25th to, all right? And therefore, this was going to be the leftovers, which is b, okay? And if you want, you could put a little 1 there if you want. So you can see that when you add the exponents, and we're adding the exponents because there's multiplication in between these two radicals, you add the exponents, and that's why that is equivalent to what we begin with, right? And then we're just going to circle this. And if we take the square root of b to the 24th, we end up with b to the 12th. Okay, we just go ahead and divide that exponent by the number in the crack. All right, so that's what that equals. And this square root of b to the first is our non-perfect, and it just comes down. And you don't have to write the 2 in the crack if you want, unless you want to, okay? And you don't have to write the little 1 exponent. And so that is in simplest radical form. All right, the square root of b to the 25th is the same thing as b to the 12th, square root of b. All right, let's try another one so we get the hang of these. Okay? So in number 6, we have a number and a variable. So you got to remember that the coefficients follow different rules to get simplified than the exponents do. And I think that's the tricky part for us. We see them as just numbers, but they are different numbers. Okay, 28 is a coefficient and 5 is an exponent. All right, so we start when we simplify them by drawing 2 square root houses, okay? You could put 2 in the crack if you want, all right? And 28 is a coefficient. So when we do 28, we're looking at this list of numbers. We're looking at the largest perfect that goes into 28, and that number is 4. So we're going to go ahead and put 4 here, and the leftover would be 7, because 4 times 7 is 28, okay? And now we have a variable, and now the 5, which is an exponent, has to be divisible by the 2 in the crack, all right? And 5 is not divisible by 2, so we go to the next lowest one. So we go to x to the 4th, okay? And x to the 4th is divisible by 2, so we're going to put x to the 4th, because 4 is divisible by 2, okay, in the crack there. And if you need to put it there, you can. And this will be the leftovers, which is just x, because x to the 4th times x, you add the exponents, and you get x to the 5th. All right, now that it's broken up, we're going to go ahead and circle this, all right? The square root of 4 becomes a 2. The square root of x to the 4 gets divisible by the 2, and you get x squared. And then you bring down the non-perfect house, which is the square root of 7x, and we box that up. That is in simplest radical form, okay? I'll try a couple more so we get the hang of it, okay? Because this process is going to get repeated when the number in the crack changes to a 3, okay? All right, so in number 7, that negative 5b cubed, it stays for a little bit until we go ahead and we break this up. All right, so 20 is our number underneath there, and the square root of 20 is not perfect, so we find the largest perfect that goes into 20, which is 4. And the other number is 5, because 4 times 5 is 20. Okay? A is not, does not have an even exponent on it, and so A is not perfect. And you can't go any lower to make the exponent on the A into an even number. And so even though we can't break up A, then A is going to live in our non-perfect house. There's really anything we can do with it. But B to the 13th, now remember there's a little 2 in the crack here, all right? And 13 is not divisible by 2. okay, because 13 is an exponent, so it has to follow the division rules of the number in the crack there. So we go to the next lowest, which is b to the 12th. And now b to the 12th is divisible by 2 there, so we're going to put b to the 12th in the perfect house. Therefore, the leftovers is just a b, okay? So that if I add the exponents on the b, I get what I started with. And now that everybody's broken up, we go back and we circle that first one because it's perfect, okay? And the square root of 4 becomes 2. And remember, there's a 2 in the crack, and all you have to do is divide the exponent of 12 by the number in the crack, and we get b to the 6. Okay? This comes down, and this comes down. And we have to remember that there's operation of multiplication between them. And now we can take our coefficients, which is -5 and 2, and multiply them, get -10. And when we multiply, we add our exponents, so that would be b to the 9th. And then the square root of 5ab comes down. And this one's finished. Okay, so let's take a look at the next one. All right, so that 3/4 is just going to hang out for a little bit. And then we're going to have a perfect house and a not perfect house. Okay. 32 is not a perfect square. So we're going to look at the list of numbers and say largest perfect that goes into 32 is 16. The other number is 2. So that 16 times 2 is 32. Okay. Remember that this is a square root, so there's a 2 in the crack. And x squared is divisible by that 2. So we're going to keep x squared. We don't have to break them up in the perfect house. Okay. And 100 as an exponent is also divisible by 2 that's in the crack. And so we're going to keep this as y to the 100th. And we don't have to break it up. So now we're going to go back and we're going to circle this nice perfect house. Okay. And we're going to arrow down, and the square root of 16 becomes the 4. Remember, there's a 2 in the crack. And so the exponents get divisible by that. And so x squared and the square root of x squared will become just an x. And y to the 100th, the square root of y to the 100th is y to the 50th. Okay. And then the square root of 2 just comes down, and the 3/4 comes down, and the multiplication goes in between. And 3/4 times 4 is 3. X, y to the 50th, square root of 2. And that one's finished. All right. So hopefully you're getting the hang of them by now. All right. And so we have number 9. So again, no numbers out in front, which is nice. We don't have to worry about that. Okay, we got our perfect and our non-perfect. Square root of 72 is not perfect. The largest perfect that goes into it is 36. And it goes in twice. Okay, 8 to the 7. So remember, there's a 2 here. And 7 is not divisible by 2. So we go to the next lowest, which is. And so we go a to the 6, which will go in the first house. And the leftovers is a. All right, b to the 9. 9 is not divisible by 2, so we go to the next lowest, which is b to the 8th. Okay, because 8 is divisible by 2, the number in the crack. And the leftover would be a b that goes in the non-perfect house. C to the 16. 16 is divisible by 2, so c to the 16th can stay in the perfect house, and there is no leftovers to put in the non-perfect, okay? I'm going to extend that a little bit. And now I'm going to go back. Now that everybody has been divvied up into perfects and non-perfects, we take that perfect house or perfect radical, and the square root of 36 is 6. All right. Some people will need to have that 2 in there when they use the exponents so that they can see square root of a to the 6 is a to the 3rd, 6 divided by 2. Okay. B to the 4th, and c to the 8th. And bring down that square root of 2ab, the leftovers, and this one is finished. All right, so hopefully you guys are getting the hang of those, all right? So just remember that the coefficients, the big numbers out in front, okay, have to be split up into the perfect squares. The exponents have to be divided by the number in the crack, all right? So if you can remember that, then you should be in good shape, all right? Especially when we go to the next page and they start changing them on us, okay? All right, let's go ahead, and I'll see you guys on the back side of notes.